Okay. All right. So let's start. Thank you very much. Good evening. My name is Andrzej Kamiński. I'm co-organizer of this meetup, and this is the first meetup of this year. End of last year, we introduced a couple of changes. I want to thank Alison Bennett, who was the co-organizer for the last 18 months, and she was helping me with leading those sessions. And I would like to welcome Ilse Bishop and Willie Schaub, who will be helping me this year. Our intention this year is to continue finding interesting speakers, companies, and products, and try to experiment with different delivery formats. Today, we are going to have two interesting presentations, but first I want to say a couple of housekeeping items. So first of all, this session is recorded. Please keep your mics muted. After each presentation, we'll have 10 minutes for questions. You can type questions anytime in the chat or unmute your microphone if you want to ask questions directly. All right, so as you know, DevOps has different flavors, and sometimes some people refer also to concept of DevSecOps. And to me, this doesn't really make a lot of sense because honestly speaking, security is part of delivery one way or another, right? This is not negotiable part of functional requirements, non-functional requirements, right? And as a DevOps, we build applications and we operate those applications, and we often assemble applications from various vendors. And some of those applications or those components are including, for example, sometimes open source, directly or indirectly. If we implement a component from a vendor that might be using some of those open source components, we might not immediately see those. But since most of the applications currently are really in the cloud, delaying updates to those applications is no more an option. Applications becoming more and more complicated, and either because we try to keep those applications secure or stable due to changing underlying software frameworks, we need to keep the track of those components. So today, our first topic will be related to exactly to this subject, and I would like to introduce and welcome Ari Waller and Bill Manning from JFrog. Ari, over to you.
Thank you so much. I really appreciate it. Hi, everybody. My name is Ari Waller, and I am the Meetup event manager for JFrog. And we really, really appreciate the warm welcome tonight here at the Vancouver DevOps Meetup community. I'll share just a little bit about who we are. JFrog is a DevOps software company known best for Artifactory, which is considered by many to be a gold standard for managing your artifacts and dependencies. In fact, one thing a lot of people don't know yet is that JFrog has a free cloud version of our Artifactory product for the Meetup community. It's not a trial version that runs out, but a free version. It's great, especially if you're working with Docker, as I know many of you are. JFrog's cloud subscription is capable of functioning as a pull-through cache for Docker Hub. And because of the partnership we have with Docker, you'll be exempt from any rate limits on free or anonymous, free pulls from anonymous accounts. So that's something that can be valuable. Now, I want to share my screen with you. We have something special for the Vancouver DevOps community tonight. Let me get to these. Where's my slide? That's not good. One moment, please. You would think that after all of this experience we have now with all the virtual meetups, here I go. This would be so simple, but it's not. So here we go. Hopefully everyone can see my screen okay now. Yes. But let me just grab one thing here, and you should still see it. But everyone see the slide okay?
Yes.
Great. And a bonus for you tonight is, since our topic is around something technical, we want to, of course, give you a technical treat. So JFrog is going to give you a chance to enter to win a Raspberry Pi 4, which, if you've tried to procure these days, it's not the easiest thing to procure. I have to order them there's only a limit of one if you can even find one. So this is one that you can get your hands on and play with a little bit. You can enter with the QR code or the bit.ly link that you see. And I'm also going to drop it in the chat. I can't do live sweepstakes online for compliance reasons. However, we will randomly select a winner within 2 business days. We will contact that winner via email. And once the winner claims the prize officially, we will go ahead and share the winner with your meetup community as well. But we want everyone to be a winner tonight, or almost everyone at least, to have the opportunity. So for the first 20 people that do enter the sweepstakes, we're going to give them a JFrog t-shirt and a liquid software book. We'll send it to you just for entering to the first 20 people. So I'll go ahead and drop that link in the chat, and I'm looking forward to hearing Bill speak tonight, and I'll let him do further introductions. But thank you, Andre and team, for having us in your community tonight. We really appreciate it. Bill, I'm going to turn it over to you and stop sharing.
Excellent. Hey guys, how you doing? I'm Bill Manning. I'm going to share my screen here, and let's just kick this off. Let's get this shindig going here. Let me move the little annoying Zoom window out of the way so it's not covering up all my stuff. All right, so how you doing, guys? So tonight I'm going to introduce you guys to SBOMs and software bill of materials, and basically the impact on enterprise DevOps. Right, this has become a huge talking point, especially for me over the past year, for a lot of different reasons. I've done this talk, not this exact talk, but similar talks to this for multiple times, both live at like reInvent and some other security things. And today I'm going to present it to you. So I am one of the solution architects / also the manager of solution engineering for the Americas for JFrog. As Ari stated, we are we're an international global company. We have over 6,300 customers, 70% of the Fortune 100. We went IPO last year. We are involved in everything from we're officially like a CVE provider. We're also members of the Cloud Native Foundation in terms of governance. So working with a lot of basically coming up with a standard that most companies can utilize to do sort of the cloud native approach. There's a multitude of things that we're involved in. I've been with the company for about 5 years. So you can follow us at JFrog on Twitter, or even follow myself at William Manning. But today, the importance of this is not only talking about software bill of materials, but what really led up to it, and really what it means in terms of organization. I'm also going to give a demonstration and show you like how we handle software bill of materials, and I'm also going to talk about the 2 different formats that are currently being utilized right now, and I'm actually going to demonstrate some of those formats to you so you understand what it entails. So we all see the news all the time, right? I mean, really, the software bill of materials has been a thing for a while, but it's really become more apparent when we see alerts like this, something from Hacker News. That's always a place where I always go to make sure to see, what's interesting out there, what exploits are happening. But the thing is, though, is what we're going to deal with today is we're going to talk about supply chain security, right? Because supply chain security in our software development is really what came about to really drive the software bill of materials idea and concept forward, especially in the United States. I mean, we see these headlines all the time. There's nothing new here, right? I mean, it's constantly, even a couple of weeks ago, I should have added in here, 2 weeks ago, the massive Log4j thing, right? I mean, one of the most commonly used libraries across the planet also happened to be one of the most susceptible. Right. And the thing is that last year alone in 2021, there was a 650% increase in supply chain attacks. I mean, that's insane when you think about it. Right. I mean, the thing is that, most people's exposure to software supply chain attacks, they've been going on for a long time. It's just that it became more publicly acknowledgeable when it came down to SolarWinds. Right. SolarWinds was really the catalyst for a lot of countries and a lot of corporations and a lot of industries to really reevaluate the way software supply chain is actually handled. I mean, when you look at SolarWinds itself, it affected 18,000 customers globally, right? It was a multi-billion-dollar remediation scale. And the thing is that it actually broke a trust model. And the trust model is that when we start talking about being developers or dev engineers or DevSecOps engineers, release managers, QA engineers, the thing is that when we go down to its lowest factor, the one thing that's important to recognize is like, I mean, actually with the, you can see from the white of my face here, I've been doing this for a long time. I started off as a software engineer and I've done a multitude of things from being a software engineer to CTO to founder to VC to what I'm doing now. But the idea is is that when you're looking at this, we have this inherent trust model that the things that we use to build the software we produce was a trust. It was a blind trust. We would bring in these libraries that we need to do our job easier. We need a function to go ahead and, do something with a string, go find something that does that. And the thing is, though, is when you bring in those libraries and we start talking about this, remember that library comes in with all of its friends. And, it's like throwing a party and you invite 1 or 2 people, and next thing you know, there's 100 people at your house and you have no idea who they are or how they got there. But SolarWinds was the catalyst, because in the United States alone, it affected the Department of Defense, Department of Homeland Security, the Federal Reserve Bank. This infected so many systems, out there, and it was a third-party transitive dependency attack. And it wasn't even a direct dependency attack. It was an indirect dependency attack, meaning it was a dependency of a dependency of a dependency that came in. And why are software supply chain attacks so on the prominent rise, right? When we talk about this, and the reason why inherently the model is broken and the things need to be put in place to ensure safety and security, not only for what you do as a job, but for your company and the people that use your products and stuff. Because let's face it, no company wants to be a headline, right? No company wants to be like X company got infiltrated based on a software attack, that was blah blah blah, and next thing you know, there's people are running and panicking and trying to figure out what happened, right? And the reason why is that number one is super low effort, right? It's completely low effort compared to most coordinated other attacks that you might have on like DDoS, or you might have like a network infiltration, or all the typical SQL injections and all that, because those take a lot of effort. Where this doesn't really take a lot. Even the technical skill required is pretty low. I mean, the thing is that associating yourself to putting in some sort of malicious code into some sort of third-party transitive dependency that gets basically loaded in like a sidecar is insane. And the thing is, it's super high speed to spread. That's the insane part, because the thing is that once you've actually introduced it into the system, it's there. And the thing is that once again, it abuses the relationship between companies' trust and this, the things that they produce. And there's always this little nagging thing in the back of your head after you're reading these things that says, can I really cause something completely terrible to happen with my corporation, or maybe even just a project I'm working on? Because the thing is that these hackers, these people who write this malicious components, they just blend into the community. They become part of the community. They add to it. They contribute to it, and somewhere down the line, they've introduced something that could be potentially threatening. So when we look at the way this happens is that as a developer, and like I said, this is all leading up to the reasoning why accountability is so important, is that, as a developer, you go and you have to code something. You go ahead and no matter, non-dependent on what language you do, you start pulling in a bunch of transitive dependencies that help you do your job better. Right? You produce your code, and what happens if one of the packages you have in here is malicious? Next thing you know, it's part of what you do, it's part of what you distribute, and next thing you know, you're putting it into a web service, or you're installing it on the device. I actually gave another talk I gave a year and a half ago. It was called like If Code Could Kill. Basically like bad programming and bad libraries that cause unforeseeable tragedies, on things that have happened. But the thing is, though, is this is not only an erosion of the actual software component itself, but also, the reputation of a company. But most of the time, it's not a direct dependency attack that actually causes the problem. The dependencies you have depend on other things. And if one of those components is nefarious, it gets dragged along with that same level of expertise. And next thing you know, you're at the same place, right? You've introduced something into the stream of what you do. And like I said, developers are inherently trustworthy. We're kind of blind trustworthy in this case by saying, these are the things I need to accomplish my tasks, meet my KPIs, meet the deadline of my sprint. I mean, I can go through all the different things, right? But the thing is that these are supposed to make our jobs easier. Now there's a level of doubt associated to it, because 85 to 90% of your software is someone else's code base, right? It really is. I mean, the thing is that when you think you're developing software and you're building it, 85 to 95% of that, 90% of that is someone else's. 99% of that contains, is mostly open source. And 75% of that contains at least one vulnerability. some vulnerability that could potentially affect the way that your software operates and also the security behind it. On top of that, 49% of that code base that was analyzed has one high-risk component. And when I say high-risk component, if you're familiar with CVE, which is kind of the standard, or CVSS score, which is also the other standard, is version 2 and version 3. There's a multitude of different ways of factoring in the viability, the vulnerabilities behind this, contain at least one item. And then the thing is, though, is 90% of the applications out there have pieces in it that are either old, out of date, or completely abandoned. So we're just saying, oh, you know what, this thing hasn't been updated since 2014. I'm sure it's fine. It's just the way it is. We bring it in, and most of the time we just check to see, and maybe if there's a problem, we go check Stack Overflow and we look for a bad example. We try to retrofit into what we're trying to do, and we spend more time messing around with that. That's just the way it happens. But the thing is that 74% of this can be actually alleviated by just simple updates. Simple updates, right? So in other words, taking a little more care in the actual transitive dependencies that we utilize as developers. And this carries over into CI processes, because now with the modern day, with DevOps and DevSecOps, you can use them interchangeably. The idea is, a lot of people do BinOps or GitOps. Whatever your organization does, a lot of times now it's more automated processes. So even it happens even out of the purview of the actual developer doing the job that they do. They work on their code, they compile it, they send it off to a CI server, maybe runs some unit tests, brings back some data, whatever. And a lot of times we're like, I don't want to update that library because potentially it could ruin what I'm doing. So when software attacks is, there's a lot of different things out there. A big one is, typo squatting, being more responsible for the things that you do, because there are people out there that create code and libraries for your code that might be an I before E except after C. They might just flip around one of the letters or one of, and the thing is that you accidentally bring in something you thought was an actual library that you wanted to use, but it was a typo. And next thing you know, you're introducing something malicious into it. Another one is dependency confusion. Dependency confusion is so prominent, it is unbelievable. The thing is that we go out there, we do a search, and we say, hey, this. Oh, there we go. The thing is with dependency confusion, the idea here is that, there are these private repositories out there, like Netflix has them, right? Here's some helpful libraries, PayPal for authentication purposes, maybe so, they're high security, Apple, there's all these ones out there. And how do you know if they're the true thing, right? How do you know if they're truly from the actual source itself? We have an example that I did where, somebody was like, we went through it. And the thing is that for what they were trying to do for their software, they're like, hey, PayPal has an auth thing and it has an analytics piece. I'm going to utilize it. It's got a write-up. These are fake. These are not real. Somebody actually went in and said they're going to go ahead and use, they created these PayPal style dependencies. You bring it in, and suddenly there's this massive, of data leakage that could be happening. We found this out with the actual auth PayPal, right? It wasn't a true auth. They actually took the credentials and sends it off somewhere randomly that could be just extracted and turned into the next wave of attacks. So the United States government, and this is actually one of the direct things that have happened, this is actually now going globally, was back in May of 2021, the Biden administration signed the executive order improving the nation's cybersecurity. Yes, I had the unfortunate task of having to go in and read this. And I will say, I fell asleep a couple times, definitely, because it's not exactly the most enticing thing you're going to read. But one part of it really stood out. And the part that stood out was, of course, Section 4, enhancing software supply chain security. This is huge. This meant that the government had actually taken the time and effort to take this seriously. Right. And this is actually, Canada is going through the same process. The EU is going through it. It's going through in Britain. This is actually becoming a standard now globally. But the important part is that if you deal with the government agency, and this is now, by the way, the avionics industry, health and medical, financial institutions are now following suit, not only the governments. And what you have to do is if you produce software, any software that you sell, somebody can request a software bill of materials. And today I'm going to explain to you the reasoning behind this and how you can actually utilize this. So first of all, it's just what I'm showing here. First of all, software bill of materials is boring in a way. And so we're going to talk about cake today instead. So first of all, when you look at a cake box or any sort of food you eat, one of the important things is you get a list of ingredients, and you also get a list of warnings. And the reason why I'm bringing this up is because actually the actual group that proposed the software bill of materials was twofold. It actually has to do with the fact is you need to know what's inside your cake that you're eating, right? You know it has a whole bunch of ingredients, right? And this is really what a software bill of materials is. It's the list of ingredients, because the National Telecommunication and Information Administration, in conjunction with the FDA and then the associated relevant industries in other countries, got together and said, this is back in 2018, and said, we need to have accountability for medical devices. We do this for food, and the FDA in America said we need to come up with, the Food and Drug Administration said we need to come up with an accountability aspect for the software that gets utilized in medical devices. Think about it, right? You don't want to have some sort of nefarious codes sitting inside your pacemaker or your ventilator these days for the past 2 years. God, I mean, right? These are things that you need to have. So this became a standard. They started proposing what would it take and what does it mean to actually have something that is safe, secure, and accountable. So basically what it is, it's just a list of ingredients that makes up your software. This includes all the libraries used, whether it's paid or proprietary, right? It also talks about access. What kind of access controls does it have? This kind of level of information. Additional information that is beneficial, and I'm going to talk about that today, is also to what tooling was used. What environmental and system variables were used when you were constructing it. Are there specific settings that you have? Are there specific versions that you're utilizing when constructing your software? Basically, it's a map to how all the ingredients that you have in your software. And it's a way to provide it to your customers to have that accountability aspect. I know there's tools out there that parse through the information, and we'll talk about that soon. But what is it used for, right? So in a lot of cases, it's actually used for maybe maintenance, right? And I'm going to show you an example of this today. Like, we talked about Log4j. We talked about, these kind of components and how you can utilize this information to help, safeguard your customers against things. So in other words, say there is something nefarious, you could provide them with a level of information to say that, by the way, yes, we shipped you code and we're sorry, but it contained this information. Those companies too, when they read those warnings, can go in and search and contact your company to say, hey, by the way, we read an article that said XYZ library is potentially threatening because it actually can go ahead and leak all of our customer data. And according to software bill of materials, you guys have been utilizing it. It's a safeguard. It's also a level of communication that's never been done before between the customer and the provider, which is actually very important to increasing the level of awareness of this sort of level of attack. On top of that, it's also used for pre-purchasing and negotiations. In a lot of cases, you could go through a legal process selling your software to a company, and they go through it, and everybody goes through and looks at the, the terms and conditions and all this stuff. This will be that next level to say, hey, maybe we're purchasing your software and we have a certain set of safeguards in place of certain things that we don't want to use. Or say you're a company, you're a small startup, you're getting acquired by another one, you need to provide a software bill of materials for the software you're using. I actually had to go through this where I actually had to spend 6 weeks with the guy who I was working with. This is like back in 2010, we were getting acquired, and we had to go through and detail out all the things that we used to build our software. And then we also found out that we had to make changes because that company didn't accept what we were doing. On top of that, it's also a way to also inform management and other asset managers and legal teams and stuff, all on the possibility of these inclusions, leaks, and potential threats that might happen. And it's also a way to ensure a level of responsibility in terms of ensuring yourself, against the companies that could potentially even throw lawsuits at you because it's one of those, we told you what was in the software. Now, the benefits of it is the way to identify, mitigate, and avoid, right? These are things I like to always talk about, that these should be things that you're doing also too in terms of security anyway around software development, right? It's also a way, as in a lot of legal teams, how many times have you guys have worked for a software company, and I've had this before, where the legal team says, hey, we need a list of all the licensing we have. We need to do a license review of the software to make sure that we're not using any licenses that are not approved by our legal department. Right? There's also a way for you to go in there and also look at the inherent risks of some of the interdependencies on the software, because it also gives you a broad view of not only the transitive dependencies that you implicitly stated as part of your development, but also the indirect dependencies that came with it. I think I see a bunch of chat information here. I actually would like to, I'll address those in a little bit if you guys don't mind. And also too, there's also environmental and system information, because wouldn't you like to know if you're producing software and you go to do a recap and say, say you're deploying version 1.1 and 1.2 is now about to go into production, you put 1.2 in place, suddenly it's performing terrible comparably, and 1.1 was actually better, and you don't want to roll back, you want to move forward, you want to see what's different. You know what, I bet you once again, Phil left the debug flag on when he was compiling, and it's accumulating stuff in the logs, and it's constantly writing, and it's slowed us down, and damn it, we got to go back and change it again and go to the next one, right? This is stuff though, but to do that, in a normal environment would take you a while, where you can go in and see this information firsthand. You can even go ahead and do basically a diff and say, oh yeah, you know what, Phil did leave it on. And then you can scream and yell and go make fun of them for a couple of weeks, whatever. But then at the same time, it also helps lower some of the operating costs, because the thing is that accountability aspect is retained in a standardized format. And we're going to talk about those formats today. One is called SPDX, which was approved by the US government. And by the way, Canada is also looking at the same format. And then there's Cyclone DX, which is another one. There's been, once again, it's the format battles, right? On who decides on what format's best. Now, saying that, we know software has a lot of stuff. Now let's get into it, right? So this is the part that I want to show, and I'm going to show you a couple of examples of it too, right? But like I said, I don't want to talk about software. I want to talk about cake. I'm actually kind of hungry right now anyway, so this will kind of go along with it. So first of all, this is a lovely cake, and you know some stuff about it, right? This is what you normally would get in software. You know it's a cake, or it might be part of a larger cake. Maybe it's a topper, right? You know it was made somebody. You know it was mixed somehow. You know it was put into an oven, or you hope it was put into an oven, or it was cooked some other method. It might be tasty. You never know, right? These are all kind of things that make up the attributes, but we also know the number one thing is used ingredients. So when we look at this, we know the ingredients that it has, right? We know that these are all the pieces that make up the software. Oh, somebody's, there we go. We know all the software that's part of it. And, like these are all the pieces that make it up. But also too, there's a whole set of instructions, right, on how to prepare this. Just because I give you a box of ingredients, I'm sure you guys have all seen the Great British Bake Off, right? I mean, it's that kind of idea, and there's that whole blind thing. You kind of have to figure it out. But most of the time, most of us wouldn't know how to do that. We would actually have to go in. Those people at least have some practice behind it. This is actually a way to say not only this is how you did it, but also too, this is how you actually made it. So when we look at it, what if it happened if we changed an ingredient, right? The thing is that maybe the library changed, but in this case, I'm using baking soda. The recipe says baking soda. What if I go and actually substitute that for baking powder? I've done this. I'll admit it. I'm terrible. But what if you did it for baking powder? You're right. Maybe they sound baking powder, soda. What's the difference? Well, there's a big difference. The thing is, and this actually is also with your software, interchangeable components, maybe one changed versus the other. How do you know? And this will allow you to look at the two different recipes, or in this case, the software bill of materials, and allow you to have a diff between them to say, oh yeah, we did accidentally use baking powder instead of baking soda. We did leave that debug flag on. Oh, we did change, you know what? Somebody just introduced a new library into this. And I'm going to show you some examples of this too. So what's inside the accounts, right? So once again, I'm a developer. I'm going through, I'm building my software. I'm doing my thing, and when I bring in all these transitive dependencies, I want to make sure all that information goes into the software bill of materials. At the same time, I can provide that to my customer base. And if something changes, I can notify them in the software bill of materials that something changed between the versions that we have. If something is nefarious in place, I can notify my customers and they have that list of that information as apparent to them. It's also an internalized list that you can maintain and look at yourself. So this way you can notify the customers based on this. So that means if you do find a component like this, you can go ahead and find all the versions of the software that contain that component based on the information of the software bill of materials. And this also means the thing is, what about cakes with lots of layers, right? That was like an individual software instance. What about things, that make up, are made up of various components like web services and things like that, right? Or interdependency models where you have one program that depends on another, or, functionality, you might have LiDAR, in like a self-driving car, you might have a LiDAR that depends on an AI function, which depends on, multitude of other facets, right? Each one of those is different. Each one of those is made differently. Each has different components. Together they work together. They might be delivered in different locations. It depends on their purpose. So when we look at something like a web service, you can think of it as a multi-tier cake. Like I said, we're going to talk about cake. Here we go, right? So in this case, maybe the helm is the hot, the helm is the frosting that keeps the web service together. But each layer of that cake can have its own set of attributes, its own software bill of materials. So when we look at something like a Docker container, even, we start looking and there's an application layer, there's a runtime, right? There's an OS. This itself could be a software bill of materials. When we start talking about a web service, same idea, a whole bunch of Docker images with their own software bill of materials, a Helm chart that can have all the information of how the pods are structured. These can be individual cases also. And if there's, say, one component in it, you can go ahead and flag that component. So the whole thing is, I'm just trying to make sure we have enough time because I want to give Willie enough time for him to do his spiel too. But the whole thing here is that, additional information. What CI/CD tooling are you using? When was the software built? What stages, of the SDLC did it go through, the software development lifecycle? You want to know, did it go through QA? Did it go through staging? Did it go into production and when? With the QA team, let's go look at the testing results that happened. You want some way of accountability. And these are things that you can include into it. You also need to know what FOSS process, right? So in other words, did you pre-evaluate some of these free and open source libraries, right? Once again, it's, free as in speech, not as in beer, kind of idea of when it comes down to, free and open source licensing, libraries that you use, which make up 85 to 90% of your software. Also, too, what environment was it used in? Was it built in? The thing is that maybe you have a CI system that's dependent on specific build versions of these kind of runtimes. At the same time, what environmental system? Once again, going back to the debug flag, did somebody go in and set, the Java heap value too high or something like that? And then also, too, is there any security and vulnerabilities that are attached inside? So saying that, I'm actually going to skip this part because I'm actually going to show you what it looks like. I'm actually going to break it down. I was going to show you some screenshots, but I'm going to hold off on that. Because I'm actually going to skip ahead to the next piece because I'm going to actually show you what it looks like. Let's go look at a software bill of materials. All right. And I'm going to show you the two formats. So this is our product. And in this case, this is our JFrog platform. But for right now, we're going to concentrate on Artifactory. So Artifactory is our universal binary repository manager. It's a mouthful to say, but it provides a lot of functions. We support over 30 package types directly out of the box. But let's go look at a build. And for this build, I'm actually going to go in and I'm going to pick Docker. I like picking Docker. Docker's super complex, right? So with Docker, and I'm going to show you the fact that I have an application that has its own software bill of materials on top of the Docker software bill of materials. So let's go look at one. This one happens to be built by a Jenkins server, right? So if I show you up here, I've got a Jenkins server that builds my pipelines and actually publishes a build into Artifactory. I have a whole bunch of transitive dependencies that I need. Well, first of all, I'm going to show you like this build here, right? So first of all, here we go. Here's your good, fun, exciting, obfuscated, Docker image layers. You do a Docker pull, you do a Docker run, and the magic happens. Well, you want to know what's inside. So if I look in here, I can show you that this actual Docker image itself is actually running a Node front end of 3.0-28, and it's running a Java backend service of 2.0.47. Right? I actually know what version of the actual software is running inside this container. It's just not, container tag number 82, right? That's the thing. This actually has quantifiable information inside of it. I can even go in and say, this is, remember I was talking about Bob, screwing up and actually, or Phil, or screwing up and actually, say Phil screwed up and stuff. I could actually go in here and actually do a diff between two images to say, hey, by the way, it looks like the Node front end stayed the same, but the Java backend changed. I can show you all the environmental and system information, right, on how it was constructed. I got to warn you, I'm loading up our vulnerability data and all this. And this to show you, this, by the way, my container that I'm showing you, I probably should have picked a different one. This thing is the worst thing I've ever created. It has every major vulnerability you could ever imagine in it, 1,630 vulnerabilities. But the thing is, though, is these are all the component layers. This is the application. This is the OS. This is the runtime. Right? I have security information on how it was actually constructed and all the pieces that are in it. I know all the licensing information around this, right? This is just how all the stuff that we collect in our case, but I can export all this information too. So I can go in here in our case, and you can see I've export SBOM to SPDX and to CycloneDX formats. And just to kind of exemplify something quickly is, remember I talked about how you could have software bill of materials that represent software that runs in other things, right? Multi-tiered applications, web services, dependency models. Even if I go back here, I'll just show you quickly, is I can go in here, and in this case, here's a build I produced. I'll go look at the build that actually produced it. If I click in here, this is actually the build I have. This is that Node front end I'm doing. I can show you here, here's the tar.gz that I outputted. Here's all 482 transitive dependencies I have that make this up, right? So this is all that multi-complex layer of software. By the way, this build for this UI has 5 dependencies defined, and it brings in 482 transitive direct and indirect dependencies. How can you attribute to all of that? But at the same time, I can also export its own software bill of materials, right? Because it has its own also. Let's go look at this, right? So I have already exported these before because I had to do it. And because, anytime you have any sort of security flaw or any sort of security issue, one of the things is accountability. So I can even show you in here, like in our product, we've actually built this in where I could say CVE, take a CVE, do a search on it, right? And this will actually go ahead and find all the versions of the software that reference the CVE. So I can use the software bill of materials to say, oh, wow, this issue has affected all these builds quickly and rapidly, right? It allows me to, within seconds, I can go in there and find all the places that something has been used of a potential threat. So knowing that, let's go in, and I'm going to share my VS Code for a second, guys, and I'm going to show you the 2 formats. So I did an export. So the one I have here is the SPDX format. You can actually do it in a couple different ways. Actually, I should probably show you that, by the way. So there's a couple of applicable ways that you can go ahead and do this. And the thing is that the formats that are the standard are the interesting part. Let me go find, here, I'll go in and do this one. Let me just grab a random version. I'll just show you because some companies will respect others' versions. So if I do SPDX, you can either do it as a tagged value, right, which is one of the tagged values. So sometimes they'll ask for that. You can also do it as just an Excel, right? So just do it as a spreadsheet if you want to do it for legal purposes, and also or for JSON. Now, for our purposes, I'm going to show you the JSON version because this is actually more of the standard because there are a lot of management tools for software bill of materials now. There's a bunch out there. So most of the time it's going to be JSON. They're going to request it, you're going to ingest it into a system, and then they're going to there's all these companies springing up now that are doing that. Also, too, you can also do CycloneDX. It's either XML or it's JSON, right? So it's either or. So we actually do export both of these. But I wanted to show you what it looks like because you're going to wonder. Well, if you look here, you can actually see like the SPDX format shows all the creation info, right? So it basically says like what it is and the organization and me in this case, Bill M. That's me. But inside, this is the list of all the dependencies, right? So there's initially just a straight list of every single one. I probably should have picked something a little smaller than this to kind of show you because this is going to be scrolling for a while. Because there are a lot of components here. Let's see. This, just to show you, this Docker image is about 900, it says 982. If you take out the abstraction in the front, this has about 960 components that make up this container. This is 960 pieces of software that are utilized to actually construct that one Docker image. All right. Now picture trying to do this in some other respect, but then it breaks it down for this. So in other words, here's a link directly in our case to ours, right? So this asks for the document namespace. And then it breaks down the packages even further. So it actually grabs all the information from all those components and actually pulls out any information that could be there, including things like checksum, the name of it. Like here's like, here's a, ant JFX jar, right? So this is actually all the information that gets cataloged. Once it's cataloged, it becomes searchable. And that's one of the major factors of why software bill of materials was brought about. Now Cyclone DX is the other, but if you look here, you can see that it's different. There are distinct differences. And the thing is, like, the US government decided on SPDX, Canada followed suit. I know that in EU, they're going with SPDX. I know that Britain, because they want to be different, went with Cyclone DX, right? It's just, but both formats are out there. And I will say, I think SPDX, is probably going to grab more prominence because I think it's an easier ingest method. I think Cyclone DX is another format too but just to let you know, both are out there. They both serve the same purpose. But if you look here, you can actually see, like, once again, it's that same level of information. It's the name, the creator. This actually has, the type in this case. And then once again, it just starts breaking down all the pieces. But instead of having an index at the top, it's actually individual components that are listed out instead. Now, saying that, understanding it and having that level of information really helps you. So when you are doing your builds, make sure that, some of the, even if you're not using our product, the thing is that you can there's tools out there for things like Jenkins. There's one that takes like all that information, some of that information is collected inside of Jenkins. You can export. There's tools out there that will go ahead and, you can point it. We have one that's kind of like this. You can point at a piece of software that you're doing and, and be able to go in and look at the components and build a component graph is what it is. You're building a component graph of all the pieces, and then you have to export it into a format that, works for, what you're doing or what your regulation is or what your customer expects. But what you're doing is it's all about accountability. It's all about understanding. And it's all about, like I said, when we were looking at something like, the log4j issue, right? I can go in here and I can say, I think I actually have it already set. I queued up here somewhere. Like I can go in here and say, log, in our product, we just say log, for J, I can go ahead, or it was log4j. I'm looking for artifacts. Sorry. Let me go in here, or actually, we'll go to packages. We'll do it from here instead. I can go in here and say, okay, let's go look for, all the pieces. All right, if I was actually doing things correctly today, whatever. I'm going to go back to packages. Here we go. But I can do searches on the things that matter to me. Or actually, I'm not doing it right now. I'm actually keep going back to there. I don't know what I'm doing wrong. I messed up before. I think I said something different. But understanding, like where things are being utilized. Like I'll show one that I know works here. Hold on here. This is my test system. I always feel like I'm inviting you into my house and I haven't cleaned up. So I've got a lot of garbage in my system. But, being able to actually go ahead and have accountability of like, here's like a Babel 6.263. Being able to say, where is this being utilized, right? I can show you every single touch point in which it's actually been used. But then I can also go ahead and, you want to understand, well, yeah, that's great. You know what? This dependency that I have as part of my build system here, well, it also depends on all these 19 other indirect transitive dependencies for the model I'm building. So the understanding, what you're bringing in and how you're utilizing is very key to what you're doing. And the software bill of materials allows you to have accountability, a little safety from your organization by informing your customers of what you're using, how they're using it, and the software that they purchased. Especially, you don't want to be that company that, becomes a headline. So the big takeaway from this too is also two. Number one, misconceptions. We hear this all the time. Can it be used as a roadmap for an attacker? Not really. I mean, the thing is that yes, they can get an idea of what you're utilizing, maybe some versions, but they can go in and infiltrate the community, but that's outside of you. That just happens, right? Protecting yourself is essential. Don't have to require any source code. There's no source code required. You do not have to do it unless it's implicitly stated by the legal teams at that company. And that's a negotiation that your legal team and their legal team have to have together to say, you know, we're going to put your source code in escrow. We're going to keep a copy of it, blah, blah, blah. I've heard this numerous times with some of those pieces. And you're not going to expose any intellectual property. The thing is, you don't really, you know, the stuff that you're building is the stuff you're building. It's like I said, it's like having a list of ingredients without the instructions on how to actually put those together. Sure, you could probably try to figure it out, but if you have all your algorithms protected and you follow safety protocols, there's nothing you have to worry about. So at the end of the day, if you want to work with the U.S. government or a multitude of governments in the industries, you know, regulated industries are now adopting this methodology. You need this. If you're going through and you want a complete list of all the free and open source stuff that you're using when you build your software, you need it. You know, if you want to understand how, what, and where, and why things were made, this gives you the ability to go in and even track things like velocity. You know, how much change are we doing between versions? It allows complete accountability at the end of the day. It also adheres to software and license compliance that you might get from legal teams, you know, outside third parties, auditors, M&As, you name it. These are things that you want to be able to easily present if you're required to. So that was a lot to throw at you in an hour, and or whatever time I just did that in. But I just want to let you know that this is kind of the level of information on what a software bill of materials is. I don't know if there's any questions or anything like that. Let me see here. Oh, I just see a lot of people with greetings and free software bill of materials. There we go. Is there any questions, or anybody have any questions for me in this respect? I can go stop sharing so I can see faces.
So maybe I can just comment. I noticed at the beginning of your presentation, you had the GitLab's hack, and message was from Ravi Lakshman. And by the way, actually, Ravi was presenting on last year, actually, in this meetup. So small world.
Very cool. But so yeah, so that's basically you know, ways to utilize it, ways to do it. Like I said, protecting your customers, protecting the software you produce, and then this is just an accountability aspect behind it. So the software, you know, these are the formats that are out there, and really it's up to you as developers, DevOps engineers, DevSec engineers, release managers, of course, to ensure security at different levels. You know, the thing is that like for us at JFrog, we have our product called X-Ray, and actually it was just voted on DevOps.com as being the top security product for this stuff. Woohoo! I'll take that as a yes. That was pretty rad. But the thing is that, you know, being able to implore tools, actually, you probably saw it. One of the things here is that, you know, as a developer in here, I'm actually working on a, oh, here's one of my cats I was talking about. You might see its tail in a second. You know, these are like, here's a bunch of libraries I'm using, right? And being able to actually identify these libraries, you know, as a developer, this is the frontline defense. This is that idea of shift left, right? We hear shift left and shift right. So this is really that idea of being able to say, oh, hey, my software is utilizing these pieces. And as a developer, I have a responsibility to go in. This is a critical issue, right? This is a critical CVE. Or even being able to even go in and use a tool like this, where we even have our, like for us, we have our JFrog CLI, and I can say audit, right? And if I can spell audit today. And in this case, this is going to go through the project I'm doing. It's going to pull in all those transitive dependencies as a model, right? So it's not actually bringing them, it's bringing them as a model. And I can take this and I can display any potential threats. And the thing is that with the software bill of materials and first, you know, shift left defense, this is a great place to do it. Also integrating this level of security into your CI process, into your release process, even into your runtime. Like we'll be introducing a runtime analysis down the road to say this component is running in your runtime right now. But the idea is that this accountability is the, you know, the thing is you want to be able to map all the dependencies, direct and indirect, that you utilize as an organization. Yeah, and then have a format for it. So I hope this has been helpful, guys.
Yeah, hey, absolutely.
Yeah.
Hey, this is Ahmed Ali, and I work at ADP. And I have a question. I wanted to know, what's the best way to distinguish a vulnerability that came from your base image versus your app code in a document?
So when you're looking at that, right? So one way to do it is actually to go in, and in some cases, the best way to do it is actually, I've actually done an experiment like this where I've actually used two different tag versions, right? To say like, here's a base image one, here's this. Or if you're doing a Docker compose and you want to look at it. So like in our product, just so you know, I know I'm plugging the product, whatever. We have the ability to actually scan that base level image before it gets put into the Docker compose. right? And there's tools out there that you can utilize to scan these images before you utilize them, right? So in our case, we use our X-ray product to say, I'm doing a Docker Compose. I want to scan this Docker, this Docker base image before I even build it. I can go in and determine whether or not there are nefarious components in there. But then also too, you can also look based on the base image and abstract that out and give it its own software bill of materials. Just so you know, you can actually pull the information out if you compose that, and you actually could see all the baseline imaging in here. Like, I'll just show you really quick if you don't mind. Let me, where's my share? There it is. Here, let's go back and look at a Docker image for a second, right? Let's go back and look at my Docker image that I have here. I'm going to show you my favorite view. Yes, I am plugging again, and I'm going to show you my favorite nerdtastic view that we show inside of our product. But here's an example here. Like, here's all those base level. Here's my Docker image. Here's all those layers of the actual Docker image itself. I could actually go in here and show you, in our case, I could actually abstract all the actual, information from that base in this case. I could actually show you all, and this is a Debian container. I can actually show you like the Debian components that actually made up this one. And in this case, you can even see here where I actually have something nefarious in here with an issue. So there's ways to do this, but there's only certain tools will allow you to have that insight. Also, too, depending on how you actually build the Docker Compose, you can also use the log function and have it show when you're doing it and it's actually constructing this stuff. You can actually pull that info out also. There's a multitude of different ways to do it.
So, Bill, could you then essentially have the default behavior be that it will not build if there is a vulnerability discovered in one of the dependencies?
Yes, in our products you can. We actually have the ability to create rules that will actually terminate a build even on ingest to say and flag a container as actually being non-viable.
So, and where is kind of the threat intel coming from with regards to the vulnerabilities?
So in most cases, it depends, right? So you have all the standard NIST sources. NIST is actually the relative sources out there for most of the software out there. There's actually vulnerability lists that are out there. There's also companies like RBS, risk-based security, they have a product called VulnDB. You can actually go and search for it, and you can actually look up a component and it can bring back those lists. In our case, we actually algorithmically and manually curate it, and we also have a team is our security team that allows us to create CVEs, because we actually create CVEs publicly. We're actually one of the few companies. I think there's just under 80 companies in the world that can produce CVEs, and we're one of them. But the thing is that that level of information on vulnerabilities, I'll just show you an example. Let me see here. Let me see if I can find an example on where those sources come from, because I actually could show you the sources themselves. Let's go to another build. Yeah, you know what? Actually, let's go back here.
Using sources like NIST provides a certain level of neutrality where people can't start pointing fingers.
Exactly. So the thing is that I'll just show you quickly. Let's go bring up one, right? So we actually have here's an example of the actual, issue itself, right? Here's a link, the CVE, and it depends. I mean, in some cases, there's really not much detail, that's provided. This is actually pretty terrible. But the reference materials it depends. In some cases, it comes from, say, in this case, here's, issues.apache, right? This is actually, the issue that caused it, right? These are actually some of the publicly available components. There's other ones here, from maybe a source from GitHub that, goes ahead and says, yes, this is the actual issue that it is. Here's the CVE component itself. You can go ahead and look it up. So it depends, though. I mean, every company handles it differently, but there's also sources out there and products that allow you to go ahead and do the searching on this and also associate those binaries to those actual potential threats. And by the way, always be cautious, because you should always go ahead and look at the actual issue itself. And when you look at the issue itself, there's a lot of the time is that whole baby in the bathwater thing of being able to say, maybe there's 100 functions in a library. Is this applicable to the usage that I'm actually doing? Because and then you have to evaluate too, Is this an internal product or an external product, right? And there's a lot of things to take into consideration. The thing is that most of the time, most people are like, it's got a vulnerability, chuck it out. But what if it's an external remote source vulnerability and you're using this on an internalized product? Or what if the fact is that the actual component defined in the CVE is something that you're not actually even using as a function? So there's also a level of expectation in terms of developers to do a little research into this if something is found, to say, hey, by the way, this really isn't applicable to the way we should do it. We should label it as such.
I mean, what I'm getting at is that this is really about visibility. People have found the other way for way too long, saying, I don't know, and they shrug their shoulders, right? So now it's like,
Right.
No, it's right there. It's right in front of you. You had to intentionally bypass that flag or that warning to complete this build.
Absolutely. And that's the thing, right? And that's one of the things that we try to protect against. But also too, like I said, the thing is that there's always that knee-jerk reaction of just disposal, right? And that's the thing, is like I said, there are things that research that developers should do, and things like that. And like you said, bypassing it, you should be able to justify the reason, right? If you don't justify it, then yes, of course, they should be reprimanded or whatever, or just say don't do that, whatever. But I see, Jacob, you have your hand raised, or virtually hand raised.
You're on mute, Jacob.
Oh, you gotta unmute yourself. I'm terrible at reading lips.
Okay.
There we go.
Yes. Okay. Yes, I have a question. Okay.
Sure.
Okay. Now, this program is being used for security, right?
Well, part of it. I mean, the stuff that we were doing, yeah. I mean, our product is actually more binary management, and security is actually just a feature of our solution. Oh.
Right. Okay, but hasn't it gotten to the point where like the whole spectrum between lock out your customers, the spectrum between security and safety has veered over to the level of security? Like, do you find that? I mean, because you were all very technically, your technical prowess is strong, but for people who have who are having trouble getting locked out of their bank accounts, seniors, isn't this an issue in programming for excessive security?
No.
What would you call that access?
There's application level security, right? Actually running the application and providing security for the consumer, right? That's more of like locking you out of your accounts and things like that. This is actually more development level security, more security around not even getting to that point, right? This is actually potential threats inside the software that might cause a problem, right? So like, you'll read things of like, so-and-so organization leaked 450 million accounts, right? That was more of an application level security. In terms of actual accessibility to the contents or the actual data in the software. Locking out people from their accounts and stuff is more of a safety measure from accessibility.
But what do you mean by leaked? Well, define leaked.
So dependency confusion attacks, right? So, or SQL injection, where you go to a website, you look at the website, there's a whole bunch of input fields on it. In some cases, a lot of hackers, what they'll do is they'll use something like there's a lot of various like SQL injector. There's a whole bunch of black hat tools that you can use. I'm not saying I used them, but I'm just saying that they're out there. But you can point them at a site and say, show me a field, show me a data field, and let me see if I can inject a query into it. So log4j, why was log4j so dangerous? This one of the biggest libraries used in the entire world. It's been used for over a decade. Why was it so dangerous? Because you can inject information into a field, right? That would go into the Log4j platform. And then the scary one that anybody could run is you can actually drop into the query field with the proper flag and say, in this case for a Unix command, you could say rm-rf/, and you can throw that in, and then what it would do is it would execute on the runtime environment and just wipe out the file system, right? So you can actually have it go in with the proper sudo credentials, and actually it would just wipe out the directory, just gone, bye-bye, right? And this came with Android phones, by the way. So you could actually do this to an Android phone. That's why Google was scrambling to put out a patch to alleviate this.
Yeah, sorry, I will need to jump in. I know there is
one question. I don't know if you're capable of answering it, but okay. Now the hackers.
Jacob, could I just stop you for a moment?
The three different categories.
Jacob, sorry, we've got another presentation. So could I? Bill, you're still here, right? Can we just wait another, I would say, 30 minutes? And there's a couple of other questions as well. So maybe you can just do it after the other presentation.
Yeah,
okay,
I'll stick around. I'm actually gonna go get a refill of water. I'll let Willie do his thing. Willie, I'm looking forward to hearing what you got to say, buddy. I'm gonna go mute, guys, and I'll come back later. I'll be back. I'll be here. So
excellent. Thank you very much. All right, so we are moving to our second speaker, and that's Willie Schaub. And Willie is not a stranger to this meetup. I have a pleasure of working with Willie at WorksABC, and he's a manager of common engineering practices. Willie knows all Elon Musk's quotes, and both of them share common interests. So today he will be talking about his experience in setting up common engineering practice at WorksABC. Willie, over to you.
Thanks, Andre. And can you just allow sharing from me as well? Somehow that just disappeared.
Oh, really? Okay.
Disabled.
Yeah, let me just do that. All right, let me just try to do that. Interesting. Sharing it doesn't work for you?
No, it says host disabled, participant screen sharing.
Oh, that's not what was supposed to be. Okay.
Well, it gives Bill time to get his water. It's all part of the script.
Okay, here we go. Can you try now? Here we go. Okay.
There we go. You should see the screen now.
Yes.
And I assume Bill is back. Great. So good evening and afternoon and morning and welcome from wherever you're joining us at today's DevOps Meetup. And a special shout out to you, Vinicius, from Brazil. It's really great to see you. It's my pleasure to give you a quick update on our efforts to establish a common engineering ecosystem at WorksFBC. So let us start by taking a peek at our roadmap. And what you'll see is, as shown at the bottom, is it's based on quite an ambitious vision to empower every engineer by standardizing our engineering practices and tools and enable continuous delivery of value to delighted end users. So from the early 2019s, we operated undercover. I heard Star Wars today, so we operated like the Rebel Alliance on the ice planet Hoth, kind of out of sight, out of trouble. And we focused on creating manifestos and guardrails that enabled engineering to build consistent, secure, and simple solutions. And you can actually refer to the Common Engineering System at WorksFBC meetup session that we delivered back in April 2000 for more details on those icy times. We also innovated our continuous integration and delivery pipelines, which was another meetup session we shared last year in June, and released our WorksFBC technical blog, which now allows us to share all our failures, learnings, and innovation with the community. back in September, everything changed for us because we got the opportunity to launch a common engineering team with a leadership mandate to empower every engineer by standardizing practices and products and stewarding guardrails, again, to promote engineering consistency, enablement, security, and most importantly, simplicity. So for the first 90 days, we focused on establishing an efficient system of highways and that enabled both our business and engineering, and ensure that our common engineering ecosystem had a common and sound vision, vibrant collaboration, and an atmosphere that encourages failure, learning, and continuous innovation. And we achieved 3 major milestones. As shown, the self-service automation, which we often refer to as the walking skeleton. It creates an Azure repo, injects an app type sample, configures and injects a YAML-based Azure pipeline, and queues the pipeline as good measure for kind of final validation of the setup, all in less than 10 seconds. If that doesn't make the developers happy, I don't know what will. We looked at working agreements, also known as cheat sheets, to guide how to work together and to create positive, productive processes. And we started a war on oh, that was a bit too fast. We started a war on waste and silos, again, by fostering collaboration through what we refer to as centers of enablement, working groups, dojos, community of practices, all of which you can read up on our technical blog. Now, for the next 90 days or so, we plan to switch to implementation mode. Now we have the highways. Now let's start implementing. And our plan is to enable and foster, steward, guardrails, and collaboration. So that for us is foundation. It's all about collaborating with each other. We want to monitor and learn from baseline metrics. And we want to open source our application type YAML-based pipeline blueprints and automate everything automatable. Thereafter, I think let your imagination soar. We are looking at things like chaos engineering, which will scare operations to no end, but that is far in a distance. We should be getting ready for chaos engineering as well. So that's our roadmap that we've set up for ourselves. Here's a quick snapshot of the extent of collaboration we actually achieved during the first 90 days with our centers of enablement, working groups, relentless banging on virtual walls, twisting of rubber arms, and stubborn push for complete transparency. So if you look at the diagram, the variety of teams, the vibrance of collaboration we achieved, and the focus on outcomes gives me the reassurance that we're on the right track and hope that we can actually achieve the unthinkable as an organization. Erasing the silos, avoiding them to regrow like weeds, establishing trust, and getting all the stakeholders to collaborate has been and will probably be one of the biggest tests for our common engineering ecosystems to date. Which brings me to my personal learnings from the challenge of launching such a team, especially when you are, like I, a software engineer at heart, and you want to remain involved hands-on with the continuous research, the learning, and the improvements. So apart from the people management, dealing with rigid, at times mind-numbing and time-consuming processes, a lack of skilled resources in the local market, which we're probably all feeling. Our team also has to remember our responsibility of operational support and quality assurance. So those are 2 other pillars that we can never forget. So balancing these with our quest for bold change and continuous innovation has and will be challenging. So creating a harmonious team where everyone takes responsibility for their action, where we have a work-life balance and where everyone is a leader, is definitely not a walk in the park. I am constantly worried about everyone in my team. We are like you in tough and trying times where remote work, isolation, and the lack of social contact is not only taking a toll on every one of us, but in my opinion, maybe rewriting our rule books for business, engineering, and work psychology for the future. An anomaly that keeps me awake at night, there's many, but this specific one, is how to ensure that everybody has an innovation mindset, has the time and the grit to take a chance. I find that many engineers can spend hours talking about a problem, but often they have no time to actually solve the problem. So they will spend 3 hours telling you what their problem is all about. And when you say, let's solve it, they say, I haven't got any time now, I have to go back and write code. So hopefully we as a community, and I'm hoping we can do this as a DevOps community, can collaborate to create some helpful guidance for the community around taking a chance, being open for failure, and also this new working environment, which some enjoy and some find extremely stressful. So my personal mission statement, which I stare at every morning, is to encourage everyone's creativity, passion, purpose, and strengths. I'm also experimenting with a variety of guidance. For example, from David Marquet, carrying around his book, Turn the Ship Around, and you can actually, oh, there you can see it. This is my holy book that I carry around all over the place, wherever I go, because it's a real leadership success story that is really, really worth the read. I also remind myself to foster autonomy, mastery, and purpose, as discussed by Daniel Pink. And as mentioned by Andre, I'm inspired by the SpaceX phenomenal innovation. And I use kind of Elon Musk's rules to simplify everything, encourage my team to automate everything automatable, to question every process. And we often provoke colleagues by asking the 5 whys, or simply just ripping out a part of an inefficient process to see what happens. And last but not least, I remember or remind everyone to have fun. And that is to combat today's stressful days of isolated and remote engineering, and to remind us of the need to balance work and life. And it's probably a reason that our most recent quarterly update looked more like a newspaper than a formal report. We wanted it to make it fun. And I think it worked. Andre, you can say later on whether you agree or not, but we got some really positive feedback on that report. So we'll have to find other cool things to do. I also work hard to create a mindset to continuously experiment and embrace failure as an opportunity to learn and to innovate. And you'll soon see this round red sticker appearing on all our laptops. And that's really to instill the courage to fail as one of the pillars of our healthy DevOps mindset. Now, what I've learned is the challenge is to avoid the fear of failure amongst engineers. All stakeholders in an organization must trust the engineering process and embrace failure and as an opportunity to innovate. And the best antidote to toxic fear of failure are leaders who are supportive and inspiring, of which we have many, plus a collective, blameless, fail-fast mindset. If you have that in place, we can start experimenting and we can start learning. Or as Elon Musk says, and I quote, failure is an option here. If things are not failing, you are not innovating enough. And that came straight from the SpaceX launch site. where they are truly experimenting. So to be successful, we need a dream team that is continuously invested in and focused on operational support, quality assurance, and innovation. So we have a team of engineers focused on operational support and innovation, and another team of engineers focused on quality assurance and innovation. Now, this is where my next challenge is coming in, to create one team mindset, aligning the innovation of both those teams within a team. And I'm pretty sure it will continue to be a challenge, again, in today's remote and isolated working model, because you can't just walk over to a desk and say, "Hi, Bill, how are you doing today? How's quality assurance, the day of quality assurance going?" You cannot do that anymore. So I believe that the secret sauce that holds us together, especially during these trying times, is trust. So you have to trust each other. You have to trust your leadership, your stakeholders, your end users, and vice versa. So it's the whole chain and back. So as mentioned on our technical WorkSafe BC blog, and I mentioned it before as well, we live and breathe by our working agreements, with an emphasis on optimizing meetings, which is another one of Elon Musk's muses, and inspire an agile, Kanban, and DevOps mindset, as well as the 5 DevOps core values. So the working agreement, pinned to most of our walls, reminds us daily what we value, steward, optimize, and inspire as one team. And our team working agreement has actually triggered a range of other working agreements, such as starting a center of enablement, or even rotating through our common engineering team. And again, I invite you to have a look at our technical WorkSafe BC blog, or ping me if you have any questions on any of our working agreements. All right, so to wrap up this quick overview, I just wanted to put all the links of information I've referenced in today's update. I hope that our journey inspires you, and that you'll actively collaborate with us on Twitter and LinkedIn. You'll find us in both places. And with that, thank you for listening. Any thoughts or questions?
Oh, yeah, I will say, man, I did love the fact that you did quote the Elon Musk thing. Another one of my favorite one of my favorite quotes is from Marcus Aurelius. The obstacle is the way, right? So always look at every obstacle in its place as not a something as a failure, but look at it as more as a learning experience for a better solution, right? So whenever you come up against that, the Stoics had it right in that respect of being able to say that. Or, I always say to people on my team is nothing's impossible, it's only improbable.
Yeah. Great.
Yeah, Willie, I'm curious to hear how you, first of all, I really want to mention how much I appreciate you recognizing the value of failure, and that failure is a necessity in order to succeed. You can't have light without darkness, et cetera, et cetera. So how did you then sell the value of failure to leadership?
Are still busy selling the value, but we actually, as I said, we actually have great leaders who are supporting us with, for example, failure. And what we started doing is we literally just started putting the quotes on our back, on our laptops. It used to be great when you were actually at the office and you could have all the stickers of importance on the laptop, but that's where we actually started advertising the need to fail. I started kind of quoting the likes of Elon Musk with our leadership. Andre, you know that very often in the morning on Teams, when you all say hi to each other, I have another quote from Elon Musk, and a lot of his quotes are actually around innovation, I guess for a reason, and his strong push for failure as being a necessity. to innovate. So we've been pushing that message. Yes, with some managers, we are still pounding our heads against the wall because you just have to get through that wall or through that silo. But I think once engineers actually realize that it's great to fail because now we can learn out of it and work together, you actually see a change in the engineers. So I don't have a secret sauce other than share that message as much as you can and support your team. If there is actually a failure, don't blow up and say we have a disaster. No, great, we have failed. So it's the kind of the way you respond. I love it, we have failed. So what can we learn from this? Let's get together, let's have a virtual coffee, and let's discuss what happened. So it's again how you work with your team and kind of how you react to the failures.
Willie, just really quick. I'm sorry, I'm interjecting it again. So I'm a mentor at Techstars 500 Startups Y Combinator. I've actually I work with a lot of companies over time. I've been doing this for a couple of years. I've had 3 exits. I've actually taken 2 companies public, all these kind of things. And so I spend my time talking with, basically you don't know if you don't try. And if you fail, you reassess and move forward, right? Do not look at the hindrance, but always go forward. And the thing is that actually you learn your best viability from those failures themselves, right? If you succeed all the time, the problem with that is that you're probably not doing it right, to be honest. You're not taking the risk, you're not taking the chance. And in a lot of cases, if you do fail, the thing is, like you said, you brush yourself off, you move forward and you say, what did I learn from that? And actually failure is always the best teacher, in my opinion. And when I was down to, like you said, the Elon Musk thing. So I did a bunch of work in Hawthorne at the SpaceX manufacturing facility where they make the rockets. And I was working with their teams down there, and they have this word, all those wordings spread all throughout the facility. Everywhere you look, there's words of that, quotes and stuff. And we do the same thing at the JFrog office. Our JFrog office is filled with all these quotes to kind of reinforce the idea that we're collective, that we do fail. And when we fail, we just brush ourselves off and move forward, as a team collectively. And our job is to pick each other up and work with each other to move forward.
Wow, I guess a lot of words of wisdom.
Sorry, didn't mean to interject like that, but I just wanted to say it's like, I feel everything that you're saying, and I totally, wholeheartazily, undeniably, 1,000,000,000% agree.
And I'm so jealous, Bill, that you were actually at the SpaceX centers. You're a gazillion miles ahead of us.
Yeah.
The other thing I want you to just throw in there is with failure as well. If we actually combine it with experimentation, you've got the winning formula. I think selling experimentation to an organization is much easier than selling failure. And then kind of, again, like on the Ice Planet Hearth, you do it undercover. You actually explain to the stakeholders that, yes, we'll do an experiment, and then we'll get to a point where we'll decide if this is okay or not. If it's not okay, well, we failed, we'll rotate around and do another experiment. And you're continuously doing experiments, failing or succeeding. And that is another way to actually sell the value of failure, is combined with experiments.
Excellent, thank you. As a matter of fact, there is a lot of other quotes in chat. I think what we are going to do, we're going to collect all of them and we're going to post them somewhere. So, that's actually a great event today because it shows the right mindset, right? Actually, everybody here in this meetup has the right mindset, which is great to hear. Okay, do we have another question for Willie? If not, then I would like to close the official part of the meeting. And Bill, if you don't mind, a couple of minutes, and Willie, there were a couple of other questions as well, so we can maybe have a quick conversation. But first of all, I would like to say thank you, Ari. Ari already left, but Bill, this was really fantastic presentation. Thank you very much. And Willie, obviously, you're doing a great job with implementing and pushing the envelope, which is extremely hard. I know it's a cultural change in organizations. So thank you very much for this. And thank you to all the participants. as always, if there is any topic that you would like to talk about, you'd like to share your experience, anything that is related to DevOps, any product that you have, please do not hesitate to contact us, and we'll schedule you for one of the next meetups. So thank you very much, everyone, and have a great evening. Thank you.
Thank you, everybody, for having me. I appreciate it, really. And Andre, guys, thank you so much. Willie, amazing presentation. Thank you guys so much for your time in dealing with me.
Thank you. So, Lorena, I think you had a question, right? One of the questions, I think.
You were looking to say, is there a way to go find Log4j components, right? Is that what you're saying, Lorena? So yes, there are different multitudes of ways to do this, right? Of course, I mean, I'll just show you an example. When this came out, we were one of the first responders to this. So like we even went out and we actually produced a free open source tool for companies to go ahead and actually, you know, point us to the software that they're utilizing. I'll put this in the chat for everybody just to kind of see, but we actually released this free to the public without even our customer base, because we believe in the fact that all software should be safe and secure, whether you use this or not. We don't care. I mean, we care, of course we care. I mean, we like customers, you know, we like revenue, you know, we're a company, right? But at the same time, and in addition to that, there are other ways to do this too. So like even in our product too, there's also search factors. You can go ahead, like I showed before, you know, every touch point that it came into. In this case, this was just a CLI tool that we released that you can point at your software and it'll build a component graph around it. So you can find out whether or not that is part of the solution that you have. All right. I think there's some other questions too, right?
Yeah, Ahmed, I think.
Hey guys.
Oh, hey.
Thank you, Andre, for mentioning. I just wanted to ask if JFrog had the ability to mark a vulnerability as risk accepted.
Yes. So you can actually go ahead and I might as well show, I might as well just keep my screen up. Let's go look at, you know, like say any of these builds here. I'll just go look at you know, any sort of build that might be here with an exception. There's a couple of different ways. Hold on, let me go in here. Let me bring up any of these. So there's a couple of different ways you can handle it in JFrog. You can either say create an ignore rule, where you can say, I want to ignore it based on either the license. This is a licensing one, sorry. It could be vulnerability or license compliance. The component, the build, the watch. The watch is how you actually detect it. It's a rule set you define. You add in a note, and then you can also say you want to have it for an X number of days. Right. So there might be times where you actually say, you know what, we want to continue on this journey. We have a release coming up. We're not going to address it just yet. We're going to ignore it now, but we want it to come back in effect. So I want to come back on February 4th. I want to be notified. That's one way. Another way that you can utilize it too is that, you know, when you have any of these components, like I'll just go find, just want to show you a high level component in this case. Oops. I'm using a beta version, so I probably should have picked one that was actually, I'm in the middle of debugging a version. Oh, let me turn off the debug. I'll do it afterwards. I don't need to do it right now. But let's go in and look at, you know, any of the other components that might be in here. I'm not scanning that one, of course. Let me find one I'm scanning. We'll go back here. Let me go in and yeah, I'll do this one. This will be good. I'll go find the descendant. Let's go in and look at, like, say, a vulnerability of any type, even one here, whatever here. So I can go in here and look at a component, and I'm just doing it from the easiest place possible. I could say, okay, I want to assign a custom issue. Now, this custom issue allows you to, you know, give it a reasoning behind it. You can change its severity if you want. You can give some sort of type justification. You can even say for the single version of it or a range of versions in which you want to do it. And then you can go in and add additional metadata properties like, you know, we're going to accept this right now, but let's go ahead and let's flag it, right? Let's label it. And then I can query on it later and say, show me all the, you know, in this case, we can go to like artifacts here. I can say I want to do a search. I want to do a search on properties. I want to do a search on key value pairs where I say, you know, review later true, right? If I can spell true. Do a search, and that will find me all the, you know, components that I flagged with this metadata property. And then I can go in and, you know, from in here, I can even throw exceptions in also. So there's ways to do this. And I can also produce reports on whether or not I had, you know, any violations that I've gone and ignored. And you can also do the same thing from here also, by the way. Of course, I picked one with no violations in it. But you know, the ability for you to go in here and actually say you've accepted this, and then you can query on it afterwards. And you can do that from the CLI also. You can actually go and use our CLI, and if you don't want to go into our user interface, everything I show you is API-able too. Ours is just a simple view interface on top of our API. I'm not gonna, there's no magic.
Thank you.
No, no worries. Let's see. I think there was any more. I've only got a minute or two left, unfortunately, guys. I do need to go. I eventually need to eat. I've been on the phone since 6:30 a.m. That's the problem with having international. I actually have a phone call tonight at 11 p.m. with my office in Tel Aviv. So let's see here. Any other questions or anything, guys? If you want to ask me now.
Yeah, maybe last one question.
Sure.
We all have to eat.
I'll song and dance for you guys if you want a little salsa. No, we're good.
If not, then great. Thank you very much. Again, thank you, Bill. Thank you, Willie. Thank you, everyone.
Thank you, guys.
Okay, thank you. Bye-bye.
Be safe, be
Thanks,
wonderful, be
everyone.
well.
Bye-bye.